Welcome to my session today, all grade 8 elite students. Today we are covering lesson 4.4, transformations of linear functions. Today's video is part 1 of the series where we are going to focus on translations, and let's see what we are learning today. Let's look at the vocabulary words. The vocabulary words for today's session are family of graphs, parent function, identity function, transformation, and translation. We'll get to know the meaning of these words one by one in the next slide. So a family of graphs includes graphs and equations of graphs that have at least one characteristic in common. So just like a family has similar characteristics or similar features, similarly the family of graphs have something common. So at least one common characteristic they have or common feature they have. Now, just like in a family you have parents and you have daughters or siblings or you have son. So here the parent function is the simplest of the functions in a family. So we start with the parent function and we calculate, that's the original function given to you in the question, and from there you calculate the new function or the transformed function. So the family of linear function that includes all lines with the parent function fx equal to x. This is called identity graph. Y equal to x. Why it is called identity? Because whatever is the value of x, same is the value of y. So all the points like 0, 0, 1, 1, 2, 2 are going to lie on this. We will shortly see the graph of this identity function also. Now a transformation moves the graph on the coordinate plane, which can create new linear functions. So the new linear functions are the transformed functions which you get from the parent graph after doing the transformation. So you have the original or the parent graph given. Then you do the transformations. As you would see in the lesson, there are three types of transformations. The first is translation, then you have dilations, and then you have reflection. So the new linear function that you get after these transformations are applied is what you get or what you need to find. Now the first type of transformation is translation. In this video we are going to focus on translation. I will give you the definition now. A translation is a transformation in which the figure is slid or it is moved from one position to another. So without being turned. This is very important. Now, so what can be the direction? Let's see. It can go up, it can go down, it can go to the left, or it can go to the right. So accordingly you'll have horizontal and vertical translations. Let's see how we have these kind of transformations and translations in great detail. Let's look at vertical translation. So when a constant k is added to the linear function fx, the result is a vertical translation. So as you have seen, gx would be x plus k. There is no grouping between x and k. K is separate. So the y-intercept of fx is translated up or down. So because of vertical translation, just remember the vertical axis, y-axis. So there are two directions in which you are going to move, up and down. So the graph of gx equal to x plus k is the graph of fx equal to x translated vertically. If k is positive, the graph moves up. If k is negative, the graph moves down by absolute value of k units. So here you can see this is the blue graph, the original parent function, which is the identity function. Similarly here this is the graph, and if k is positive it moves up, so you get the orange graph. If k is negative it moves down, so you get the green graph. So this is called vertical translation. So a summary of vertical translation would be that vertical translation happens when you add a number k to another linear function. For example, you add x plus k and we say gx is the vertical translation of fx by k units. If k is positive, translation is in the upward direction. If k is negative, it is in the downward direction. Some examples would be x plus 3. So here k is 3, which is positive. Here k is 1.5, which is again positive. So it is going to go up by 3 units and up by 1.5 units. However, if k is negative, it is going to go down by 3 units and down by 0.5 units. Let's look at an example of vertical translation. Here, the translation of gx equal to x minus 2, you need to define as it relates to the graph of the parent function. So we take for x some values. Here we have taken 3 points, minus 2, 0 and 1. So fx is equal to the identity function. So it is going to have the same value. So if it is minus 2, 0, 0, 1, 1. For fx minus 2, we are going to subtract minus 2 from this column. So minus 2 is minus 4, 0 minus 2 is minus 2, 1 minus of minus 2 is minus 1. So what is the point? X and y. So x comma y would be minus 2 comma minus 4, 0 comma minus 2 and 1 comma minus 1. So you plot these points. Minus 2 comma 4 would be this point. 0 comma minus 2 would be this point, and 1 comma minus 1 would be this point. So join the line, you get the green line. So this is the graph of gx, and as you see, the value of k is minus 2, which is less than 0, negative. So it is going to go down by 2 units. Also, the constant k is not grouped with x, so it does not affect, it affects only the y values, and this is an example of vertical translation. So the value of k less than 0 tells you that fx equal to x is going to go down by 2 units. So this was an example of vertical translation. Next example, you have to say which direction the graph is going to move. If you look here carefully, x plus k, so k is minus 1, which is negative, and because it is less than 0, it is going to move in the downwards direction. So it's an example of vertical translation where k is negative, making the graph go down. Let's look at horizontal translation. In horizontal translation, the constant h is subtracted from the x value before the function is performed. So you are going to compare with gx equal to x minus h, and here x and h are grouped together. I hope you can see the brackets. So the x-intercept of fx is translated left or right. Horizontal translation means you are comparing with x-axis, the horizontal axis. So you have two directions, left and right, to go. So if h is positive, the graph of fx is translated h units right. As you can see, the blue graph has moved to the right by h units. This is the new graph, the orange one. And if h is less than 0, the graph is translated left by absolute value h units. So the green graph is the new graph, and you can see every point on the graph moves in the left direction if h is negative. So as an example, a summary of horizontal translation is given here. So you are going to compare with x minus h, and we know this is horizontal translation of fx by h units. As an example, if you are comparing with x minus h, you have your h as positive. That means it is going to move to the right by 2 units here and by 1.5 units here. However, if your h is negative, that means the translation is to the left. For example, you have x minus of minus 3. Just compare this with x minus h. So how much is your h? H is minus 3. Here h is minus 5.5. So the graph is going to move in the left direction by 3 units and 5.5 units respectively. Okay, let's solve a question on horizontal translation. First of all, how do you know this is horizontal translation? It is because you have brackets and x and the number are grouped together. So we are comparing with x minus h. So your h is negative here, which is minus 5. So very easy to understand that gx is the translation. It is horizontal and the graph is going to move 5 units left. So if this is the blue graph, the original graph, then you move each point 1, 2, 3, 4, 5 units to the left and you get the new green graph. Also, let's have a look at the table, how the table will help you to draw the graph. You take some values of x. Here we have taken 3 points, minus 2, 0, 1. Calculate x plus 5. So add 5 to this, you get this. Now calculate f of x plus 5, that is the same value. So the points are minus 2, 3, 0, 5, 1, 6. So these points, when you plot here and join them, you get the green graph. This is an example of horizontal translation. Here the constant h is grouped with x, so k affects the input or the x values. Let's do a check question. Describe the translation in gx equal to x minus of minus 12 can be written. So you compare it with x minus h. So how much is your h? It is negative 12, less than 0. So which direction it is going to move? It is going to go on the left side. This is an example of horizontal translation because you see the brackets and x and h are grouped together. Let's have a look at this flow chart of translations. There are two types of translations, vertical and horizontal. In vertical, there is no grouping between the constant and x, so your k is outside the x. If there is grouping between the constant and the x, like x minus h, then you have horizontal. So I'm just going to write here. If your gx is of the form x plus k, that is there is no grouping, then you have vertical. You are going to look at the value of k and decide whether the graph is going to move up or down. And for horizontal you have h. Here you have grouping, so it will be x minus h. It will be together. Okay. Now, if it is k positive, it is going to move up. If it is k negative, it is going to move down by k units. If it is h positive, it is going to move to the right by h units. And if it is h negative, it is going to move left by h units. So here you need to change the sign. This is less than 0. This is more than 0. It is positive. Okay. So this is a summary of the two types of translations. Let's see a combined example. This is multiple translation. That means vertical and horizontal are happening together. So you can compare with x minus h. This is the grouping plus k. So if you compare, your h is 6, your k is 3. That means both are positive. Therefore, the graph is going to be the translation of horizontal 6 unit right and vertical 3 units up. So you can check how it is moving. This point on the graph, 1, 2, 3, 4, 5, 6 and 1, 2, 3. So this is the new green graph. Also, you can check from the table of values. Here, x value is taken these points. Then x minus 6 is taken these points. Then x minus 6 plus 3 is taken as these points. So you do the calculation and the point comes out to be minus 2, minus 5, 0, minus 3, 1, minus 2. So here, this is how you solve the question. Let's look at some examples from your math book. Here I have provided the solutions. You have to compare your value of horizontal and vertical translation. Since here you see there is no bracket or grouping, so this is the value of k. This is an example of vertical translation and the graph is going to move 11 units up. So you can see here how the graph has moved 11 units up. This is going to be an example of vertical dilation. Again, this is an example of vertical dilation where your k is negative minus 8. So it is going to move down by 8 units. Next is where you have the grouping, you have the bracket. So this is an example of horizontal translation. So H is 7. So the graph is going to move to the right by 7 units. Again, this is an example of horizontal translation where H is negative. So it is going to move to the left by 12 units. Next is a combination of horizontal and vertical. So you compare with x minus h plus k. So your h is minus 10, which is negative, and your k is also negative. So both are negative, so it is going to move down by 1 unit and on the left by 10 units. Again, for this one, your h is 9, your k is 5, both are positive. So the graph is going to move down, up by 5 units and right by 9 units. That's how you solve these questions on translation, vertical and horizontal.